Okay, so in the last chapter, we built a model for predicting football results based on the Premier League data of the past few seasons, and we've saved the model in a pickle file, um, in a directory in our project, and now we can access it whenever we want to apply it to new matches. We have now so an expected points, goals, models that provides information about the expected performance of teams, and this can be compared with the odds offered on matches on different markets. Let's focus, however, on the money line 1x2 market here. So we will just predict who will win a certain match, or how will the match end, like for example in a draw, or in a home team winning, or the away team winning. Cool. So the scenario that we're gonna model now, we're gonna test on real data. So probably this season data, let's see. And we're going to follow these steps. We'll collect the data for the current season Premier League, English Premier League. We'll use the data of the first part of the season to extract the team stats. So let's say we will use the data of first 10, 11 matches. Then we'll apply the model that we have trained in the previous season, on the previous seasons, to predict the expected points for all teams given their performance so far. And then we will compare the expected and the actual points to find which teams are under or overperforming. And that will give us information about potential value bets in the market. And we'll use historical closing odds. So we'll kind of simulate a betting strategy on some of the fixtures of the Premier League. So first of all, let's create a new notebook. We'll call this notebook number 5. Let's just rename it. We call it 5, and we could call what we're going to do. We're going to apply the model in this notebook. We'll just import the usual stuff. I will just copy paste from the previous notebook because it's always the same stuff. Pandas, NumPy, Matplotlib, all our friendly packages. And now we need to load the dataset. Let's have a look at what we loaded in the previous chapters. So I think in the chapter number 3 we were loading the dataset, and or chapter number 3, yes, probably get the data here. So you see that we loaded the dataset this way. We'll just copy paste again. DF is our data frame. We'll read the CSV from footballdata.co.uk, and E0 is the English Premier League, 23-24 is the previous season. So let's try to read for the current season, 24-25. Now we have imported everything into the data frame, and we can have a look at what it looks like. df.head file. We can have a look at what this data frame looks like. The usual information that we found in the previous version of the data tool: home team, away team, full-time home goals, full-time away goals, result. It summarizes who's won what, who's won the match. Also goals at halftime, and a series of information about match statistics and the betting odds from different markets and different bookies. All right, let's call this df. Actually, let's call this df underscore EPL 23-24, 24-25. Sorry, 24-25. Right, df EPL 24-25, and we can just do everything at once and we make sure that we have the right data. Cool. Now we have many columns. Let's. Many of them are not interesting, so let's drop some of them and keep only the ones that are useful for us. The ones that are useful for us, of course, are the ones related to the home statistics, the match statistics for home and away teams. and also the odds. We will call the new data frame df underscore EPL 2425, and we append clean to it because it has less columns. It's kind of cleaner version of the data frame, and it will be exactly the same data frame as before, df underscore EPL 2425, but where we select only some columns. The columns we select are okay, I will just copy paste from here. Let's say home team, and then from here away team. Then what we want is the full-time home goals and full-time away goals, and then we want the statistics: home shots HS, away shot AS, shots on target and away shots on target, right? HST and AST. So let's do it a bit more tidier. Home shots, away shots, home shots on target, away shots on target, and the odds. Yeah, the odds. We will use Pinnacle odds. Pinnacle odds, PSH. The odds for a home team win, the odds for an away team for a draw, PSD, and the odds for an away win. I think we have everything. Yeah. We also want to add the full-time results, to be honest. FTR. Okay. This should be all, yeah. Let's have a look. Cool. This is a cleaner, lighter data frame. As you can see, it only has 3, 6, 9, 12 columns. It's more manageable. And you can see, like, for example, that Manchester United Fulham was probably the first match of 2024-2025 season. Ended 1-0 for United. And the odds for a home win was 1.63. Decimal odds. Draw 438 and away win 530. And we also have all the information about the goal, the shots and the shots on target for home and away teams. Great. The next step is to split the dataset, as I said before, in two parts. We're going to calculate the stats of all teams in the first part of the season, and then we apply them to the following match. Like, for example, the first, I think 20 or 19 maybe matches, and then we can apply to the matches, to the 20th or 21st match. And this way we can verify, for example, how good is our model when we apply to betting and to predicting actual future results. So usually you don't want to, right? I mean, the amount of data is not enough. Maybe you need to wait probably something like 6 to 8 fixtures at least to make sure that your model is stable enough. But for the sake of this exercise, let's leave a warm-up period of 9 fixtures before starting to calculate the team stats and then use them to predict the match's outcome. So we can split the data frame in two parts: the first 9 matches and the first and the rest of the matches. This way, we just create the first data frame, df_1 will be df_EPL 2425 underscore clean, and then we clean, sorry, and then we will just select with iLock the first 9 matches, like this. Okay, this way the first contains the first data frame will contain the first 20 matches. The first 20 matches is like the first game weeks, or match weeks, and the second one could be something like this. This is just to show you how to do it. This one could be from the 20th to the rest, okay? So the second one will contain all matches from the 20th so from the 20th to the last match that has been played. So from the 3rd, 21st, sorry, from the 3rd to the 3rd game week to the current game week. Now, but what do you really want to do now, since there are 20 teams in the Premier League and 10 matches per game week, we want to split the data frame into chunks of 10 matches. And then we're going to use the first n-1 fixtures to predict the nth fixture, right? So we will always be able to, when we predict a new fixture, the next fixtures, to use the most updated statistics about the team. So, for example, when we want to predict the 10th match day, we were going to use the first 9 fixtures. The 11th match day, we're going to use the first 10 fixtures, and so on and so forth. To generalize the process, this process of splitting a data frame into, like, as I said, n-1. So we want to predict the 10th fixtures. 10-1 is 9. We will create a small function that we can apply iteratively for all fixtures. So we can, like, say, okay, we want to split, you want to predict the 12th game week. We apply these functions for the 12th game week, and then split automatically the data frame into the first 10 matches, 11 matches, and the 12th one. This function will be called split data, and it's based on the fixtures. So, right, we will split data before and after a specific fixture, so the 9th, the 10th, the 11th, and so on and so forth. So the number of matches, as I said, is fixture times 10, right? Fixture times 10. So if we are on match day 3, we have 30 matches played at the end of match day 3. And then the f1 will be similar to what we've done before. The f_1 will be the f EPL the f_EPL 24-25 clean ilock, right? And then what we want to do, this one, selected the first n matches, so up to matches, right? This way, and semicolon. The f2 will be exactly the same, just you start from matches and you select the rest. So I understand. So you understand that now we have 2 data frames and we want to return both of them, df_, df_. Perfect. So here, for example, if we give fixture 2, right? Let's for example give fixture 2. We will have a split of the first 20 matches and the first and the last whatever matches are left. But actually what we want to do is to return only the match of the next fixture. So let's say, for example, say that we have 24-25, we played I think 20 fixtures so far, 20 match weeks. What we really want is probably not to split the data frame from like the first 9 and then the last 11, but to split the data frame like the first n and the successive fixtures, so the first 9 and the 10th fixtures. So we need to limit the second data frame from matches to matches plus 10, which are the next 10 rows, so the next 10 matches which are contained in a single fixture. This way we will split always first 10 fixtures n+1, as I said before. So we use the first 10 fixtures to predict the n+1 fixtures, and not all the successive ones, because it wouldn't make sense, right? We'll have to use more data. Cool. Split data we've done. Now what we do, we need to calculate the team stats, right? So we need to use these 10 fixtures or whatever fixtures, first n fixtures, to calculate the next team stats. Calculate the team stats and then predict the results of the next fixtures. So let's say we want to analyze, I don't know, fixture 15. I would say 15. Or let's say fixture 10, since we said that more or less 8-9 fixtures are the warm-up period. First of all, we need to calculate the stats for all teams up to that point, right? So before fixture 10 is played, we have 9 fixtures, and we're going to use the functions to split the data frame or our results into 2 data frames. One data frame will be called df_epl fix9. So these are the fixture. These are all the matches up to and including the 9th match week. And the epl match 10 will be the second one. Will be the only the matches of match week 10, and we will call it split. We will use it we'll create it by using by calling split data 9. So split data 9 takes the first 9 fixtures and returns 2 data frames with the 9th, with all the matches up to and including the match week 9, and with the 10th match week. Perfect. We can, for example, we can have a look with epl fix9 contains, you say, 90 rows, as we expect. Again, it starts with Manchester United, Fulham, and so on and so forth. While df_epl match 10 contains only 10 matches. You can see from 90 to 99, 10 matches. Newcastle, Arsenal, Bournemouth, Manchester City, so on and so forth. What we will do, we will kind of mask the results, try to predict what is going on, and try to predict not what is going on, the actual result of the match, and see what how our model is doing. Liverpool, Brighton, Ipswich, Leicester, from Brentford. Nice. To calculate all the stats, we can use the function that we've built in chapter 5. We had a calc fits function, so there is no point in reinventing the wheel. We will just go back to our notebook, and which is build 3, the notebook number 3, build features, and we have this calc fits. You see how this is a very simple function that calculates all the shots on targets, shots against on targets against endpoints of a specific team given a set of matches. We can give, for example, to calc fits the first 9 match weeks, so we'll get all the statistics for a specific team. We can give it in input df_epl fix9 and it will give us the output, the stats for the team. So let's apply this function. We can simply do, first of all, we extract all the teams. The Premier League, we can take it from df_epl fix9. And it'll be teams, home team, team.unique. So this will tell us, we'll take basically all the home teams that have all the home teams that have played a match in the first 9 fixtures, and create a set. So remove the duplicates. Let's see. We can have a look at the result, right? Just to double check that everything is correct. yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. We have 20 teams as we expected. Now we continue. We create all teams stats, which will be a list where for every team we will have the stats that will be calculated using this function calcfits. So every team will have shots, shots on target, shots versus, shots on target versus, and points, and so on and so forth. For example, and so how we do it, we just loop on the team for teaming all teams, and we create team stats by calling calcfits, the function, on what? On the df EPL fix9, right? Taking into account all the first 9 matches of the season, and the team name, team. And then we will append to all teams stats this data frame, this result, which is a list. Okay, if we execute this, we'll just wait for the loop to happen. Oh, error. We need to modify slightly the calcfits functions. We just replace the f with the FEPL, right? Because it's what we're going to give it as an input, or we just add just modify here the f as the FEPL. That should do the trick. Just execute again. Perfect. Now we have all teams stats. Looks like this. A team, again, Manchester United, the shots on target, shots against, shots on target against, and points up to game week 9. So we know that Manchester United up to game week 9 had 11 points and 130 shots. Arsenal 18 points, also 130 shots, 50 on target, and so on and so forth. But shots against is a bit different. Everton, Newcastle, you see, you have all the results in all the teams of the season 2024-2025. Now we have the statistics. It's probably all we need, right? We have all the statistics of all the teams played the first 9 match up to ninth game week, match week of the Premier League, and we can simply apply a model to our model that we have trained in the previous part, and we can apply the model and extract the expected points, compare the expected points with the extracted with the actual points, and actually build or predict if the teams that will face each other will have a home team win, a draw, or an away team. Before doing that, let's save the team stats in a dictionary that we will call df underscore all underscore stats as a data frame. And we can just construct a data frame this way: df all stats equal pd data frame all team stats, and we'll have team shots, more tabular data, and much easier to read than a dictionary, and also to manipulate. We've saved the model, so now we apply the model. We are ready. We have saved the model in the previous chapter, so now it's very simple to load it as a pickle file. First of all, from job-lib, we import dump and load, and then what we do? The features of the model are df all stats, and then we add like shots, right? It's everything apart from team, no? Shots underscore ot, shots vs, and shots otvs underscore ot underscore vs. Perfect. The model is just load. We can just load. Let's see what we have here. Dash data slash what we have, where is the model? EPL model 2325, 2324, sorry, job leap. And if we are lucky, it's just as simple as doing model dot predict and giving the features as an input. And we'll have the expected points, because the model is a model that predicts the expected points. Cool. It's an array with all the expected points of the teams. So, for example, it's probably for Manchester United we have 15, for Ipswich 4.8, for Arsenal 15.4, again for Everton 9. I mean, more or less, it will actually be exactly the in the order that we have given it to the model. So the order that we have here in the data frame, from the first to the last row. And yeah, perfect. So what we can do, we can just add to the data frame a new column that will be called expected points. So df all stats. We will add a new column. We call exp points. Exp underscore points, or xp points. Exp points is fine. That will be model dot predict features. This is model predict features will give us an array. We will save this array, this list, into a new column, and df underscore all underscore stats. So yeah, we want to add expected points, but we also want to add the expected points difference, right? Because here we have the points of the teams, but we want to know if they're over or underperforming. So we want to know the difference, and we will call this new column exp point diff, the difference, which will be df all stats exp points. So we will do points minus df all stats points, right? So if the value is a positive, the expected points of the team will be higher than the points. If the value is negative, the expected points will be lower than points. So in one case, when the value is positive, so we write it here, positive, the points is underperforming, because the team is underperforming because it's expected to perform better. When it's negative, the team is overperforming because he has more points than expected points. Wonderful. Yeah, we can execute the cell, and then we can have a look at the df all stats. And we'll see that it has two new columns. For example, let's have a look. Overperforming Manchester United up to game week 9. Wolves also overperforming. Crystal Palace overperforming. Underperforming. Right? It's a positive underperforming. Manchester United underperforming. Wolves underperforming. Palace underperforming. Overperforming slightly. I mean, Liverpool overperforming. Aston Villa overperforming. Newcastle, Brighton, and so on and so on. Chelsea. Leicester too. Okay. The value betting part now. Now we have expected points, actual points. The easiest thing to do, or the most natural thing to do, right, is to bet on teams that are underperforming to regress to the mean. That's one of the strategies that we can use. Let's have a look at the matches from fixture 10. Let's first let's say save all these matches in a data frame. So what we've done before, here df EPL match 10, right? df EPL match 10, contains home team, full-time away home team, full-time home goals, full-time away goals, the results, and also the statistics. What we want is to extract the odds, which are PSH, PSD, and PSA. So they are the odds for home win, draw, and away win, and used information, combined information of odds before the match and expected points to somehow build a strategy that will give us information about what are the value bets. Okay,